Welcome to Tech Talks Education. We are going to continue with Avogadro's principle and the molar gas volume. Last time I remember giving you values of the molar gas volume at room temperature and at standard temperature and pressure. So we have already known that those values we shall be given either on the front page of our question paper or at the end of a question, if ever it's supposed to be used in that very question. So today we are going to see how to use the values of the molar gas volume at STP and at room temperature in calculating some few quantities. So we are going to look at calculations, involving equations. Calculations involving equations. And these calculations are called stoichiometric calculations. Stoichiometric calculations. Actually, these are calculations in which an equation is involved. Either it is given or you are supposed to write an equation for the reaction that took place, and then you use that equation in your calculation. So it is called stoichiometric calculation, in that we shall be strictly dealing with the number of moles of each chemical species in the equation. That is the number of moles of the reactants and then the products. So let us see some examples to this effect. Let's look at this. Carbon burns in excess air according to the following equation. Let's see the equation for the reaction in this case. It is carbon burning in excess air, and in air we have the active component being oxygen gas. Burning involves oxygen gas. So we are using excess air, meaning that the product that is going to be got in this case is a product of complete combustion of carbon, in this case which is carbon dioxide gas. If it was an incomplete combustion where we have a limited supply or insufficient supply of air, then we would get carbon monoxide gas. Now, we are supposed to calculate the volume of carbon dioxide produced when 4 grams, let us say produced at STP when 4 grams, let me say 4.0 grams of carbon burns completely in excess air. And these values may help us. The relative atomic mass of carbon is 12, and then 1 mole of a gas at STP occupies 22.4 cubic decimeters or decimeters cubed. So let us try to see how to go about with this calculation. This is a stoichiometric calculation whereby we shall strictly deal with the number of moles of atoms or of the particles of each substance in this equation, I refer to them as being chemical species. Now, we have seen that 1 mole of carbon reacts with 1 mole of oxygen to produce 1 mole of carbon dioxide. That is in a burning or a combustion process. Now, we are supposed to calculate the volume of carbon dioxide produced at STP when 4 grams of carbon burns completely in oxygen in excess air. We are going to do this. We have seen that there are 3 chemical species here: carbon, oxygen, and carbon dioxide. So, firstly, take note of what you are going to use in your calculation, and you will get it from the question after the equation. Calculate the volume of carbon dioxide. Volume of carbon dioxide. So we are going to deal with carbon dioxide produced at STP when 4 grams of carbon. We are also going to deal with carbon, meaning that we are not going to deal with oxygen, or we are not going to use it in our calculation. The air is in excess. That means we have a lot of oxygen, and we have not been told the actual or the definite quantity of oxygen used here. So we are using carbon dioxide and then carbon. Now, for the carbon dioxide and the carbon, that's the chemical species you have identified, you need to look at the number of moles of each of them. In this case, carbon dioxide, we have 1 mole produced, and carbon, 1 mole burns completely in excess oxygen to produce 1 mole of carbon dioxide. So what you are supposed to do next is look at the number of moles of each of those 2 substances and then convert it to either mass or volume as per the question. So for carbon dioxide, we are calculating the volume of carbon dioxide, meaning that the 1 mole of carbon dioxide, we are going to convert it to the volume, but that shall be the volume at STP, whose value we have been given here. And then as for carbon, we have been given the mass of carbon, meaning that even this 1 mole of carbon, we shall convert it to to mass. So make sure that you convert the number of moles of each of the chemical species you are going to consider in your calculation to either volume or mass, that is to the rightful quantity. Now, let us try to see. Carbon dioxide, we are dealing with the volume, and we have 1 mole of carbon dioxide. Already 1 mole of a gas at STP has a volume of 22.4 cubic decimeters. That one is okay. And then as for carbon, we know that 1 mole of carbon, we have been given that carbon equals to 12. So this value of 12 here is the value of the mass of 1 mole of carbon. Matches, it is the relative atomic mass. The relative atomic mass of carbon are the same in value with the mass of 1 mole of carbon. It is what we saw earlier on. So, from this equation, what are we calculating? We are calculating the volume of carbon dioxide. So, from first principles, we are going to make sure that carbon dioxide gas goes to our right-hand side, and carbon, whose mass has been given, will be on our left-hand side. What we are calculating goes to the right, and what we have been given, we shall keep it on our left-hand side for the sake of simple cross multiplication. Now, in this case, we have 1 mole of carbon. Since carbon will be on our left-hand side, we shall have carbon on this side, and we are going to convert the number of moles of carbon to the mass. So 1 mole of carbon has a mass of 12 grams, and we shall say 12 grams of carbon, 12 grams of carbon burns to produce, now carbon dioxide, whose volume we are trying to calculate, will go to our right hand side. So 12 grams of carbon burns to produce 1 mole of carbon dioxide, whose volume is 22.4 cubic centimeters. So it produces 22.4 cubic decimeters rather. And then what of this volume, what of this mass of carbon which has been given? So the 4.0 grams of carbon, this one here, burns to produce. Then we look at this. In this case, what we are going to do is we shall cross multiply directly. This one will be multiplied by this, and we divide by this. There is no need for us to use X or Y or any other letter here. We just cross multiply directly. This second quantity, which is on the second line on our left hand side, we multiply with the second quantity, in this case here, with the 20.4 cubic decimeters, and we divide by the first quantity. So let us multiply 22.4, which is our second quantity on our right hand side on the first line. We multiply by our first quantity on the second line on our left hand side, that is by 4.0, and we divide by 12. And the unit, we shall have to put it here. So this is the importance of starting with what we have been given and what we are calculating. We take it to the right hand side. So let us try to get this one here, the answer, using our calculator. So 22.4 times 4.0, and we divide it by 12. Our answer is 7.466666667, and the unit remains the same on the same side of our work from first principle. So this is the volume of carbon dioxide gas produced when we burn 4 grams of carbon completely in excess air. Now, I said that when you have got a long or a large decimal number, please first write the whole of that figure. Then if at all you are to say round off, then you can round off to any number of decimal places, but that will be an approximate value. But the exact value is this, according to what we have got from the monitor of our calculator. So it is 7.5 to 1 decimal place cubic decimeters approximately, and that is the answer we have got. So as you have seen from what we have done, we firstly identify the substances we are going to use in our calculation right from the question that we have after the equation, and after that we look at the number of moles and convert the number of moles to either mass or to volume as per the question, or as per what the question says. Then the substance whose quantity you are going to look for will go to your right hand side, and the one whose quantity has been given remains on our left hand side. But we start with what we have in the equation, then you come to what we have in the question. That is for simple cross multiplication. As we have seen, we have to multiply diagonally 4.0 by 20.4 as we have done here, and we divide by this first quantity 12, and we have got the answer. Now let us look at another example. So remember that the 1 mole of carbon, we converted it to the mass. Let us see where we have not been given an element but a compound. So let us see a compound. Then importantly, we shall see how to convert the number of moles of that compound to the mass. It will be an application of the calculation of relative formula mass as we had seen. So let us try to see this. Calcium carbonate decomposes according to the following equation. So the equation is this: calcium carbonate produces calcium oxide and then carbon dioxide gas. This is the equation for the decomposition, the full decomposition of calcium carbonate. So calculate, let us still calculate the volume. Calculate the volume of carbon dioxide produced at room temperature. Oh, we are changing the condition now to room temperature from STP to at room temperature when 20 grams of calcium carbonate decomposed completely, given that the relative atomic mass of calcium is 40, the relative atomic mass of carbon is 12, the relative atomic mass of oxygen is 16, and then 1 mole of a gas at room temperature has a volume of 24,000 cubic centimeters. Remember, I said that the value of the molar gas volume will be given to a candidate and for a candidate to use. So you need to strictly adhere to the volume that you have been given. So we have been told that this reaction here took place at room temperature. And then we have been given the molar gas volume at room temperature being 24,000 cubic centimeters. Do not be given the molar gas volume in cubic centimeters. Then for you instead forget and put liters or cubic decimeters. Adhere to or strictly continue with what you have been given, and then you have to make sure that volume remains in cubic centimeters. Now, off we go. Calculate the volume of carbon dioxide. Oh, we shall use carbon dioxide in our calculation. Produced at room temperature when 20 grams of calcium